Alright guys, welcome back to video number 2. We're going over shielded metal arc welding with aluminum. What we did is, I had given you the basics guys. Why would you want to do aluminum? If you really think about it, if I have the option, I'm definitely going to TIG weld it, or I'm going to at least MIG weld it. The stick aluminum is really based off of, I'm out in the field, the part is in service, and I need to keep it running. Like I said, I maybe did this 1 or 2 times a year. So what we did is we come out here, we got our pound worth of aluminum rod, and what we did is we laid this down. Now let me explain something to you guys about aluminum. Remember in an earlier module we talked about being able to read a weld. And what you got to understand is this. That was my first weld. Now if you look, none of the slag has been removed, so the weld looks extremely messy. That's not what I'm looking at. If you look at the excessive hard spatter that's off to the side, what that tells you is you're either A, long arcing, or B, you're too hot. So what I did is I ran this weld to see that I was too hot. Then I went to this weld. This weld looks a little bit better. The slag has been removed. You can see there's not any spatter off to the sides of the weld. But the thing about this weld is it's real texture. If you look, the toes aren't tied in real well right here. Then as the metal gets hotter, the toes tie in a little better. But what I realized is reading this weld, it's too cold. What I'm trying to tell you guys is this. If you ever take your fingernail and you rub it down a weld, and if you listen to the sound of that, you can tell my fingernail is jumping off the ripples. Each ripple is kind of standing up, and the toes aren't tied in quite as well as I like it. So then we go to this weld right here. This is weld number 3. Now if you look here, this is where the toes have the best tie-in and the ripples are at their smoothest point. This is where my heat was, and just to let you guys know, I ended up dialing this 1/8" rod in at 105. Now, what I want to tell you guys is this. When you look at these welds, you're like, Ron, those welds look pretty rough. That is why a lot of welders do not run stick on aluminum. Most welders will tell you it's for emergency purposes only. But as a fill welder, if the part's got to stay in service, you have got to figure out a way to make it happen. I doubt that any stick welding on aluminum would ever be to a code, but it will at least keep the part functioning until it can be taken back to the shop for a proper repair. So when we look at these welds, you guys, that's what we read on them. Now, on this last weld, I didn't do a start and stop. If you guys look really close, I have an exposed crater there, and I have about 1 inch more to go. That's what I wanted to explain to you guys. I had left that intentionally for a reason. This is another reason why they don't like doing stick on aluminum. A, it's very hard to make it look good. And just so you guys know, for those of you that know me in stick welding is pretty much my game, and that's almost as good as aluminum as you're probably gonna find. But, so it's hard to make it look good. But secondly, what you're gonna find is these electrodes are consumed extremely fast. These coupons are only cut to 5 inches. So what does that tell you? That means a full rod won't even make it 5 inches before it's consumed into the weld. So you don't get the deposition rate. It forces a welder to have more start and stops in a part. And you advanced students know the more start and stops you have in a part, the harder it is to make it look good. So I left that for a reason, just to show you that it won't even make it past a 5 inch rod before I'd have to reload another one and go back into it and do a start and stop. And hopefully a welder is good at start and stops. Now, we've already said I run direct current electrode positive. We've identified that 95 amps was too cold, 120 was too hot. We learned that 105 on our machine was where it is, and we learned that by reading our weld. Welders say, well, how do you manipulate it? You don't manipulate it. You treat it just like stainless or 7018, where basically you set your work angle of what you want. I set about a 10 degree travel angle. You folks that know me know that I prefer less travel angle in my welds to help them lay down flatter. So I probably gave it a 5 to a 10 degree, and all you do is just drag it along. I will tell you guys one thing. If you have arc length issues in your welding, where a lot of you guys long arc and you long arc for a while before you see it, Aluminum rod is going to give you fits. It's better. It's just like stainless. The tighter the arc length you can keep, the better. Okay. So that's our aluminum, you guys. I hope you got something out of it. But if you have any questions, just message me on it, and we can get something figured out, you guys. But like I said, stick welding, at least understand it so you can implement it in your game and possibly make those parts stay in service a little bit longer. We'll see you in the next video.